The heart morphogenesis, the heart is the first functional organ in vertebrate embryos that beats spontaneously at week 4 of development. So it's the first organ to function actually in an embryo, and it starts beating at week 4 of development. So for the cardiac looping, it says that primary heart tube loops to establish left-right polarity. So basically the heart does have two sides, the right side and the left side. This looping that's called primary heart tube loops, they start doing so in the week 4 of development. So it's there. If we find some kind of defect in the dynein, it's a defect in the left-right dynein, that would be or end up as a left-right asymmetry. So there would be asymmetry in the two sides of the heart. Can lead to dysarcardia. So this result is actually the main portion of the heart being on the right side, which is abnormal. It should be on the right, on the left side, and that could be seen in Cardiovascular syndrome. That's something that we can get to later. For the septation of the chambers, so it's a series of steps. Let's say for step 1, so that basically these are the shapes that we're going to see. So for step 1, the septum premium grows towards the endocardial cushions, narrowing the ostium premium. So in this figure that we have here, number 1, what we have basically that's already there is dorsal endocardial cushion. It's this thing, and there is right atrium over here and left atrium over here. And what we need, or what is starting to begin, is something called septum premium. So for septum, it means like something to isolate two parts, while ostium is actually a hole or an opening. So there's already a huge hole in week 4 between right atrium and left atrium, but by time it's going to be closed by this green growing thing that is going downwards toward the endocardial cushion. So this is called septum premium. So it's the first thing to develop. It just goes down to the dorsal endocardial cushion. That's for step 1. For step 2, the ostium secundum forms in septum premium due to cell death, and that is ostium premium regression, during ostium premium regression. So let's just stay in the step 1 first. So as we said, that the basic or the original hole that we have in here is called the ostium premium. That means the first opening that is already there, and the growing septum, the green thing, is the septum premium. So for step 2, what we have is the still growing green thing that is called ostium septum premium. That is what is called ostium premium, and basically it is kind of closing the huge hole that was already there. So it's closing this huge hole, but at the same time it's growing downwards, as we said, but at the same time it is growing, and also it's regressing. There is some cellular death over here. So the cellular death over here causes it to have an opening. So the original opening that it could not close yet, it didn't reach the endocardial cushion yet. So there's the original opening. The original opening is what we know is called the ostium premium. This is it, the ostium premium. This is the original opening, and the new opening that starts to develop in the ostium secundum due to its cellular death, due to its regression, is called the ostium secundum. Okay, so that's the ostium secundum. For number 3, there is septum secundum develops on the right side of the septum premium as ostium secundum maintains right to left shunts. Okay. So there, in the image here, the ostium premium gets to the endocardial cushion, and it closed the original opening that was there, that was ostium premium. It's not there anymore, but the secondary foramen, that is the ostium secundum, is still there because it's just there. So at the same time, there is a developing septum secundum, and it is this blue thing, and it grows to the right side of the septum premium. So it's always on the right side. That's something to be known. Okay, so for number 4, this says that septum secundum expands and covers most of the ostium secundum. The residual foramen is the foramen ovale. So now we're talking about the blue septum that is called the septum secundum. So it keeps growing and going downward, and it basically, because it's growing, it covers most of the opening that is left, and that is the ostium secundum, as we remember. So it kind of not close it, but I mean it covers it. It just goes down over it. So it's this opening, then it just covers a huge part of it. But there's only one small teeny tiny part that is not closed, and that is called the foramen ovale. So this is how the foramen ovale forms. It's just because the septum secundum covers most of the ostium secundum. So, and we still, of course, have some parts of the septum premium. It just didn't all fade away and go away, so it's still there. So, yeah, that's why. And for number 5, it's the remaining portion of septum premium forms the one-way valve of the foramen ovale, because as we said, the septum secundum, the blue thing, does not completely close this opening, that is the ostium secundum. So it still has some opening over here, and that's considered one-way valve, which means it just goes up, lets the blood go from the right atrium. This is left atrium, so it just goes this way, only this way. So it's only a one-way valve. So but what happens in point 6 and 7 that is not shown in the image is that the septum premium closes against septum secundum, sealing the foramen ovale soon after birth, because the increase in left atrial pressure and decreased right atrial pressure. So basically, because these are really too close together, the green thing, that is okay, is it the green thing? It's the septum premium again. Yes, so it's the green thing. This one closes against the blue thing. So it just basically, the septum premium closes against the septum secundum. So when it closes, that's soon after birth. And why is that? It's because of the increased left arterial pressure and decreased right atrial pressure. And that's something that we can understand later by time, because it's just is due to the I think it's due to the respiration of the baby. So for point 7, it says septum secundum and septum premium fuse during infancy, early childhood, forming the arterial septum. So during infancy, that is a period after the baby is born, and then there is childhood, that is the period after infancy. So they fuse together, the blue and green, and they just fuse together and form the interventricular septum between the right, the interarterial septum, atrial septum, that is between the right atrium and left atrium. So what we have now is in a disease that is called patent foramen ovale. It just goes by the name. The foramen ovale that we talked about stays patent, stays open, and it's of course due to failure of the septum premium and septum secundum to fuse after birth. Most are left untreated. We don't just always treat those, because most of them are just left there. It can lead to paradoxical emboli, that is venous thromboemboli entering the systemic arterial circulation through right to left shunt, as can occur in atrial septal defect. So there is some kind of emboli that is called paradoxical emboli. It's a venous thromboemboli. So what we have here is, let's say this is kind of an adult, let's just consider it kind of an adult heart. So what we have is that superior vena cava and inferior vena cava, they bring blood from all the systems to the heart. So that's called venous return. So this venous return has some kind of emboli, let's say, and this emboli goes into the right atrium. if there is normally, I mean, in normal baby, in newborn, or normal human, that should be closed, so there is no connection in here, no easy connection in here. But let's guess someone has patent foramen ovale, like this one, or someone who has atrial septal defect. It's also a defect in the same place, in between the two atria. So if there is an opening between these two atria, that means this emboli, the one that came from the superior vena cava, came to the right atrium, then goes right to the left atrium. From the left atrium, there we go, it goes to the left ventricle, and from left ventricle, of course, it would go all the way to the aorta. That's how we get the how it gets into the systemic arterial circulation, because the aorta goes to the